right, so second day of our transformations is today. We're going to talk about horizontal and vertical shifts as a summary. That's what, all the work that you did on Friday and over the weekend. So the first bullet we're looking at, let's make sure we read the if statement. If f of x is our basic graph, some parent function, some graph that we're looking at, and c is a positive real number, then what's going to happen in each of the following situations? Let's say we have a transform function g of x, which is f of x plus c. Then how can we describe what's happened to the graph of f of x? Anybody? Yep, Jesse? Shifted c units upward. Perfect. Okay, again, we don't know what the operation is. We don't know whether f is squaring input, square rooting it, cubing it, whether f of x is some kind of piecewise function. We don't know what f of x is. But what we can see is that the operation has occurred. The operation has happened. So the adding of c is post-operation. It's after we've already performed whatever f tells us to do to x, and then we've added c to that output. So what is changing is our output value. The output value is changing. Okay, so we always have to identify whether it's the output that's changing or the input that's changing. And whenever the output changes, as in these first two situations, it's a vertical transformation. And in this case, whenever you add and subtract, because today we're going to be multiplying, or if you want to think of it, multiplying or dividing. But whenever you add or subtract, it's literally the shape stays the same, and you're just literally moving your graph either up and down the y-axis along the y-axis or right and left along the x-axis. So this is a vertical shift, both of these, and then this one we'll get to in a second. So following the same logic, what would we say for the second bullet? Isaac? C units downward, right. Okay. Again, notice your function has already been performed. And, we talked, quickly on Friday about post-operation. If you want to make the story like being in the hospital and after the operation is over, your goal is to be vertical. So post-operation is a vertical shift. Right. Now we're going into new territory here. Now everything that's happening is pre-operation. It's happening before you even get to perform the function f, whatever the function x tells us. So this is pre-operation. And remember, that is affecting our input. And if you think about pre-operation, you're horizontal, right? You're either in bed getting ready for your operation or you're being rolled into the operating room. So this is horizontal shifts. And this is where life feels a little bit different. Everything seems to be a little bit of the opposite way or inverse way of thinking about it. So when we actually add a positive number to the input, what happens to our graph? Someone want to, yep, Dylan? It shifts left, C units, right. So when you see X plus C, you often think of going to the right, but in this case, we saw that our graphs actually move to the left. And therefore, the last bullet, Laurencio? Right. Okay. So that's a summary of what we did on Friday. The next page, if you have not completed this page, please make sure this is done no later than Wednesday this week, no later than March 8th. And I'm giving you all this advice because if we looked at our revised syllabus, our schedule, we know that today we're in the second day of transformations. We're finishing up on Friday. So Friday's going to be a combination of everything we did on Friday and everything we do today. So having the class activities done for these first 2 days of transformations is going to be really important for Friday's work. And Friday, you'll be picking up your take-home quiz. Okay, so Friday is, we're finishing up transformations on Wednesday, and Friday you pick up the take-home quiz. So that way you'll have another day or so, 2 days, to absorb all the transformation information before you actually get your quiz, which will be due on Monday the 13th. Okay, so that's sort of the schedule. But when you see something like this, and notice I've been doing these tables here to help you take a look at how to actually perform each transformation that's happening here. So when you look at this function, g of x, what are the two transformations that are happening? How would you describe the two transformations that are happening to f to get g of x? Jesse? A vertical and horizontal, right? So we know we've got a vertical and a horizontal shifts, right? We've got two transformations, vertical and horizontal. Also, please note how vertical is spelt. I see lots of projects where people spell vertical CLE instead of CAL. So you may want to make a note if you've looked at your own handwriting and you have LE. Okay, can anybody tell me specifically what the shifts are that are going on here with the G function? Someone that maybe hasn't had a chance, James? Okay, that's one of them. So Jane says that vertically, we're having a vertical shift down. That's the subtraction symbol. They're down 4 units. And then the one that's a little trickier. Yep, Cyrus. Right, horizontal shift right, horizontal shift right. 2 units. So that's, now, if you were, following this table, you would start with point A, which is -6,5. You're going to become very familiar with this particular function. You're going to see it quite a bit. And I'm just having you transform each coordinate based on what the transformation is. You can do it like this in tabular form, or I'll show you another way. So the horizontal shift right of 2 units means you're going to add 2 to all your x coordinates. So this would then become -4,5, because you're just working on your x coordinate first. And then your vertical shift down 4 units says y take away 4, you're subtracting 4 from your y value, so then this would be -4,1. So your final coordinate is -4,1. So -4,1 is right here. So that's, I'm going to call that A star. That's my new point. It's been transformed. Okay. So this is going through what we did last Friday. You can go through the table like this for all 5 points and then graph your new one. The other thing you can do is you could literally take each of your points, -6,5, and I'll just do 2 of them for you, -2,1. And you can do these little arrows like this. And notice I have 2 arrows because I have 2 transformations. And I could go like this. Oh, I'm going to add 2 to my x value, which gives me -4,5. And now I'm going to take my y value and subtract 4. So this is doing everything that the table does. It's just in sort of a horizontal arrow type mode. Some students really are, can handle doing both of them at the same time, and they literally just take care of their x and take care of their y. It's always nice to show what you're doing, though. So if you did something all in one step in your head and you put that there and you made a mistake, either with your adding or subtraction, I know that you knew what to do, and then I could see where you made your mistake. Okay. So either of these formats is fine for getting your new transform function G. All right, so today we have a demo activity, and our function looks a little bit different. We talked about shift changing in Friday's class, going up and down the y-axis, left and right. And today we're going to practice on a new parent function. It's not x squared, it's not square root of x, it's not x cubed, it's not y equals x. It's a new function called f of x equals the sine of x. And this is what we call a wave function. And you're going to learn more about this if you end up taking pre-calculus. And if you go to applied calculus, you won't really see a sine function. But we chose the sine function starting with this semester because it really illustrates the ideas of transformations in this section much better. And there's no ambiguity when you look at a sine function. So notice if we were to just look at some points for this sine function, we would have the point 0, 0, just to show you some of the points. The point here would be 1.57 comma 1. The point here is 3.14 comma 0. Then we have the point 4.17 negative 1. And then notice we're right back at 6.28, right back to 0 again. And we start this sort of motion all over again. It's what we call a cyclical or periodic function. So that's the whole range of this function from -1 to 1. The whole function is graphed in that very tight band from -1 to 1. Okay? And it just keeps repeating itself forever and ever in both directions. Right? So the questions that you have for your preview activities involve taking what you learned in Friday's class and applying it to this function. So why don't you take about 5, 6, 7 minutes or whatever to complete this, and then we'll move on with today's material.